Sir Isaac Newton was born in Lincolnshire, England on Christmas Day in 1643, the same year that the great Galileo died. Newton was born into, and his entire upbringing took place during the turbulent times of the War of the Roses.
What these manuscripts reveal is a very different Newton than most people conceive of. This is a Newton who is not a cold, calculating scientist. This is revealing Newton in all his glory, warts and all, if you will.
When he turned 21 in 1664, he enrolled in Cambridge University, where he immersed himself into his studies unlike his classmates, who went out
drinking, going after bad young women in local villages.
To avoid temptation, Newton came up with this plan that he stuck to for his entire life, which was:
the way to chastity is not to struggle directly with incontinent thoughts, but to avert she thoughts by some employment, though by reading or meditating on other things, or by converse. For he that's always thinking of chastity will be always thinking of women.
When Cambridge closed due to the plague, Newton returned home and sat under that famous apple tree. And
instead of thinking about girls, he's thinking about the moon and how it goes around the earth and so on. And an apple falls, and the story goes as bang, he suddenly has the idea that the same thing that's making the apple fall is what's holding the moon in its orbit.
Newton himself said the apple falling helped him
realize that what held the planets in orbit was not a physical mechanism like Descartes' clockwork, but an invisible force he called gravity.
Some pundits, like this guy, seem to be:
I'm extremely skeptical about the role of fruit in Newton's life.
However, other pundits believe this incident gave Newton a certain scenario, which was:
what would be the speed of an apple which is constantly accelerating at every point along the way? What would the apple's velocity be halfway to the ground? To find out, you can measure the apple's average speed over smaller and smaller periods of time. The shorter the time interval, the closer you get to knowing the apple's speed at that moment. But to find its precise speed at a single instant, you have to reduce that time interval as close to zero as you can.
Newton invented a way to make that time interval infinitesimally small. What is infinitesimally small? That is smaller than any number that you can think of. It's not zero, but it is smaller than any number that you can think of.
For the first time, it was possible to calculate quantities that are constantly changing, like the speed of a falling apple at any particular moment, or how a planet's position changes over time.
This ability to calculate quantities that are continuously changing is one of Newton's great discoveries. Newton also used calculus to prove the inverse square law, which states that as you get closer to the sun, gravitational pull is stronger, and when you get 2 times the distance away from the sun, gravitational force gets weaker.
From analyzing the stock market to modeling global climate change.
While Newton was still home, he did several experiments on light that
overturned accepted wisdom about how colors are produced, performing an experiment on himself with a large needle, or bodkin.
I took a bodkin and put it between my eye and the bone, as near to the back side of my eye as I could. And pressing my eye with the end of it, so as to make the curvature in my eye, there appeared several white, dark, and coloured circles.
After the whole bodkin experiment, he found a safer way to test light with a prism, as pictured. But once the colors were on a wall, he put another prism up to the red light, and this proved that
The prism actually is a separator of the objects that are all in the original light. This was very hard for almost everybody to swallow, because it meant that when you're looking at white light, you're looking at something which has all the colors already in it. This seemed completely counterintuitive, and indeed, frankly, it's counterintuitive to most people today.
In 1669, while Newton was at Cambridge, which reopened in 1667, Newton invented a new kind of telescope, a reflecting telescope, which has no lenses. Therefore, it has no discoloration in what you view. This diagram shows how it works. Light is focused with light contacting the small mirror, which is then reflected back to the mirror, and then the light is focused to the eyepiece. This innovation allowed him to join the Royal Society. When Isaac Newton became a professor at Cambridge University in 1669, he also began to study alchemy, which is a prelude to chemistry and concerning principles with dissolving methods for transmuting baser metals into gold, and with finding a universal solvent and an elixir of life, the philosopher's stone.
What his aim might be, I was not able to penetrate into. But his pains, his diligence, as those times made me think, he aimed at something far beyond the reach of human art and industry.
However, Newton's alchemy was a
systematic process with results that could be reproduced and verified.
Sir Isaac Newton.
He's not a madman playing around with strange spirituous substances. He's trying to actually figure out how to change material particles around to get one thing out of something else.
After some period of time, Newton started to refocus and left alchemy to write his baby, the Principia.
After the publication of the Principia, Newton is the man. I mean, you know, very few people can understand what this thing is about, but a lot of people can see there's something important in it.
The thing that was so important in the Principia was that it gave a new framework for understanding the universe by using his 3 laws of motion, which were created to explain motion everywhere, on land and in the heavens. These laws are: an object at rest will remain at rest forever unless acted on by an external force. An object's rate of acceleration is proportional to the force exerted on it. For every action, there is an equal and opposite reaction. And these showed
To know how gravity works on Earth and in the skies, Newton designed a thought experiment.
Imagine a cannon being fired on Mount Everest. According to Newton's first law, the cannonball would travel in a straight line forever, but gravity pulls the cannonball down. If the ball is too slow, it will land at the base of the mountain. The faster the ball goes, the farther the ball will land. If the ball was fired fast enough, the cannonball would get into Earth's orbit and stay there. Lastly, Isaac Newton was quite a religious fanatic. He felt that Christ isn't God's equal, and he also took time to comb the Bible for clues to Armageddon. It's not this year, folks. It's in 2060.
That is a beautiful way of persuading you, me, and probably his colleagues that cannonballs falling to the Earth and the moon falling to the Earth is one and the same law of physics, gravity. The moment that he realized that, almost everything else follows from that.
Lastly, Isaac Newton was quite a religious fanatic. He felt that Christ isn't God's equal, and he also took time to comb the Bible for clues to Armageddon. It's not this year, folks. It's in 2060.
The most beautiful system of the sun, planets and comets could only proceed from the counsel and dominion of an intelligent and powerful being.
That is what Newton thought. He thought that God must be there. Without God, the world would not exist. Newton died in 1727 at age 84, and he's buried in Westminster Abbey among kings and queens.
Man was a complete genius. I mean, people like Newton, if I shoot off the hip, maybe once in 500 years, at best.
This is the egg drop experiment, which proves Newton's first law of motion, which is an object at rest stays at rest until an external force acts upon it. And in this experiment, the external force is myself when I strike the pie pan, the cake pan. So here's the experiment. As you can see, the egg fell off the tube as I strike the pan, so it worked.
There is no disputing, there is no refuting. We're all indebted to Sir Isaac Newton.